percentage yield for Cambridge IGCSE Chemistry. Cambridge uses the terms actual and expected yield to calculate percentage yield. I'll take you through that and then give you 3 exam style questions on the last 3 slides. The term expected yield is the maximum amount in moles of product calculated to form in a complete reaction. So let's take an example, the maximum amount of ammonia, NH3, produced by the complete reaction of 6 grams of hydrogen. Well, we need to calculate that. So we need a balanced chemical equation, hydrogen to ammonia. We recognize the mole ratio, the reacting mole ratio of 3 to 1 to 2. We now need to convert 6 grams into a numbers of moles. 6 divided by 2, the molar mass of hydrogen is 3. So we've got 3 moles of hydrogen. 3 moles of hydrogen will make 2 of ammonia. 3 moles of hydrogen will make 2 moles of ammonia on complete reaction. So the mass of 2 moles of ammonia, 2 times the molar mass of ammonia, 14 and 3 makes 17. So 2 times 17 equals 34 grams. The expected yield on the reaction of 6 grams of hydrogen is 34 grams of ammonia. But expected yields are often not obtained for a small number of reasons, which I'm going to list here. The reaction may be reversible, that is, some of the product may be converted back into reactants. Side reactions producing byproducts may exist. Procedures and/or errors may result in the loss of product. A student in the school laboratory may drop some crystals rather than transferring them into the weighing boat. So, expected yields are often not obtained. Which brings us to actual yield. This is the amount of product that is measured to have been made. So reactant A and B make product C. What is the actual yield? Is the amount of product C that is measured. So we can measure mass using an electronic balance. We could measure a volume of a gas. We could measure numbers of moles in solution. However, at GCSE, the focus is generally on yield calculations based on the mass of a product, although strictly all 3, mass, volume, and volumes of solutions, can be used to calculate the numbers of moles of product. So let's use actual and expected yield to calculate percentage yield. So percentage yield is a straightforward numerical comparison between actual yield and expected yield. Percentage yield equals actual yield divided by expected yield, and we turn it into a percentage by multiplying the product by 100. So you are expected to recall that percentage yield is actual over expected times 100. So let's do an example just to clarify. If the actual yield of ammonia on the reaction of 6 grams of hydrogen was only 11 grams, rather than the expected yield of 34 grams, we would calculate the percentage yield to be 11, the actual yield, divided by 34, the expected yield, times 100, comes out to be 32.4%. The percentage yield of hydrogen was 32.4%. So here is the first of 3 slides with exam style problems. Number 1, calculate the percentage yield in which 6.6 grams of product was obtained for the expected yield to be 10.6. So you've got actual 6.6, expected 10.6, calculate percentage yield. Stop, restart to check. Okay, so here's the answer. Actual divided by expected, 6.6 divided by 10.6 times 100, 62.5% is the yield. Second problem, ammonium sulfate is made by reacting ammonium hydroxide with sulfuric acid. If the expected yield of ammonium sulfate was 114 grams and the actual yield was 110, calculate the percentage yield. Stop, restart to check your answer. Okay, so actual divided by expected, 110 divided by 114 times 100, 96.5%. So our second problem is more complex. Calculate the percentage yield for the reaction below. So here is the balanced chemical equation. Given that 16 grams of iron oxide produced 4.8 grams of iron in excess carbon monoxide. Stop the class. Can you calculate the percentage yield? Come back to check my working when you are ready. Okay, so here's my reasoning. The mole ratio between iron oxide and iron is 1 to 2. I need to convert 16 grams of iron oxide into a numbers of moles so that I can predict the expected numbers of moles of iron. So the expected moles of iron oxide, or the reacting moles of iron oxide we're starting with, is 16 divided by the molar mass of iron oxide. 2 times iron, 3 times oxygen, 160. So we started with 0.1 moles of iron oxide. Well, we would expect that to form twice the number of moles. So we would expect to form 0.2 moles of iron. How much did we actually form? 4.8 grams. But we need to convert that into a number of moles. So the actual moles of iron, 4.8 divided by the molar mass of iron, 56, comes to 0.0857. Now we have expected moles and actual moles. So we go into the usual routine, actual divided by expected, 0.0857 divided by 0.2 times 100 comes to 42.9. So here is the third problem, and it's a variation. Calculate the actual mass of methanol, CH3OH, formed by complete reaction of 8.6 grams of hydrogen, given a percentage yield for the reaction of 52%. So here is the balanced equation, 2 hydrogens, 1 carbon monoxide to form methanol, 2 to 1 to 1 is the reacting mole ratio. With that information, can you calculate the actual mass of methanol obtained? Stop the class, try the calculation, come back to check when you are ready. Okay, so we need to turn 8.6 grams into a numbers of moles, so we divide by the molar mass of hydrogen H2, comes to 4.3 moles. It's 2 to 1, so we would expect 2.15, half that number of moles of methanol. 2.15 moles is the expected. If we know that the yield is 52, we know that actual divided by expected times 100 came to 52. So actual divided by expected times 100 equals 52. So we're going to solve for A. So A, rearranging, is 52 times 2.15 divided by 100. So the actual moles of methanol that is formed is 1.118. But we're asked for the actual mass of methanol. So the final step is to convert the moles of methanol by multiplying by the molar mass. 12, 3, 16, and 1 comes to 32. So the actual mass of methanol achieved 35.8. So the key to this calculation is to work out the expected numbers of moles, but then realize that actual over expected times 100 equals the percentage yield. Well, we can, as long as we have two of the variables, we can solve for the third one, the actual moles in this case. So 52 is equal to actual divided by expected times 100, and we go from there. Well done for finishing. If you need more practice, I would suggest look in your textbook and then past paper questions. There's the physics and maths tutor website. Nothing to do with me, just has unlimited past paper questions. If you'd like some more classes related to this topic, look at the playlist and the links in the video description. If you found this class helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Please like, and any comments much appreciated.